Hi everyone. Today we're going to be talking about changing a repeating decimal to a fraction, and the reason that's important is because yesterday we learned that a repeating decimal is a rational number, and to be a rational number it has to be able to be written as a ratio. So we are proving that a repeating decimal is a ratio by changing it into a ratio, therefore is a rational number. Before we go from a decimal to a fraction, let's remind ourselves how to go from a fraction to a decimal. So I chose an easy one, 1/3. 1/3. And what this line right here, that fraction bar, that means division. So what this is really saying is 1 whole divided into 3 parts. So you divide 1 by 3. So the 1 goes on the inside, the 3 goes on the outside. 3 goes into 1 0 times. So because we have no numbers, we can put a decimal, because 1 point is the same thing as 1. So we're going to put a decimal point there. 0 times 3 is 0. And we're going to subtract. So just a reminder on how to do long division. And then since there isn't any numbers, we're going to put a 0 and then bring it down. 3 goes into 10 3 times. 3 times 3 is 9. So then we are going to subtract, bring it down. Bring another 0 behind it, bring that down. 3 goes into 10 3 times. 3 times 3 is 9. And hopefully by now you can see this pattern. No matter how many zeros we put in here, it's always going to leave us with 3 up here in our answer. So 1/3 is the same thing as 0.3 repeating. So what we're going to do today is go from the repeating decimal to the fraction with this really neat set of rules or set of steps that will get us the correct answer. So here are the steps to changing a repeating decimal to a fraction. And if you were in class, I would have them covered up, and we would talk about each one at one time. So it's going to be tricky for you to write notes at the same time as you're watching the video. But if you're watching the video, hopefully this is for the first time by yourself, and then we'll go over it in class, or for the second time, and you already have the notes completed. All right, so the first thing it says to do is put the repeating decimal equal to x. So we are going to take the repeating decimal and just put it equal to x. Step 2 is multiply each side of the equation by a power of 10. If there's one repeating digit, you're going to multiply by 10. If there's 2, by 100. If there's 3, by 1,000. If there's 4, by 10,000. So you're going to have the same number of zeros as the repeating digits. So in this case, there is one repeating decimal. So we're going to multiply both sides by 10. So that gets me 10x equals, and at any time, if you remember, you multiply by power of 10, what you're really doing is moving the decimal over one place for every 0. So 1.3 times 10 is 13.3, and since the 3 is repeating, we're going to put the repeating bar over it. Then it says, step 3, rewrite the first equation under the second. So here's my first equation. It comes down. So x equals 1.3 repeating. Now remember, when you have a decimal and you're subtracting, well, we're not to the subtracting, but when you have a decimal, it's important that you line up the decimals. So here we have the decimal point here, so I put the 1.3 repeating underneath it, but I lined up the decimals because the next step is subtracting. I'm going to subtract this equation from this equation. So that gives me 10x minus x is 9x. So it's like if you have 10 apples and you subtract an apple, you have 9 apples left. And 13.3 repeating minus 1.3 repeating, well, the 0.3's cancel out, so then it's just 13 minus 1 is 12, and you divide by 9 to solve the rest of the equation. Remember, if it's multiplied, we have to divide. Lots of things going on here. So x is 12 ninths, and if you reduce that, it is 1 3/9, which is, if you reduce that even further, 1 1/3. From here to here, by the way, we didn't really reduce, we just wrote it as a mixed number. 9 goes into 12 one time with 3 left over. So we learned on the last example that 1/3 is the same thing. 1/3 is the same thing as 0.3. We did that division. But now we worked backwards. Here's our 1 whole, and the 1/3 and the 0.3 are the same. So 1.3 repeating is the same thing as 1 1/3. And using these steps, you can get it every single time. So let's try another example. So if you look back at your notes, the first step is putting the repeating decimal equal to x. And the next step is multiplying by a power of 10 that is the same power as the number of repeating decimals. And since there's only one decimal that repeats, we are going to multiply by 10 on both sides. So that gives me 10x equals, remember when you multiply by a power of 10, you move that decimal over. So now we have 4.4 repeating. And again, the reason we get that is if you had 0.4 and you multiplied by 10, you would get 4. But remember that with the repeating decimal, there are lots of 4s after that. So if you move the decimal over one place, there's still more 4s behind it. So that's where the 0.4 repeating comes in. All right, so the next, you rewrite the first equation under the second, making sure to line up those decimals. You subtract, so 10x minus x is 9x, always. And 4.4 minus 4, or 4.4 repeating minus 0.4 repeating, is just 4. And it's multiplied, x is multiplied by 9, so we have to divide by 9. So x is 4/9. And if you put that into the calculator or work the other way, how many times does 9 go into 4? Just to double check yourself. 9 goes into 4 0 times. Carry down the 4. We didn't have anything else over here, so I put a 0. 9 goes into 40 4 times. 4 times 9 is 36. Oops, there we go. 4, put another 0, carry it down. 9 goes into 40 4 times. 4 times 9 is 36, and you can see that pattern. It repeats. So it's 0.4 repeating. So we know that we did this correctly. Okay, one last example, I believe. The first thing we do is put our decimal equal to x. This time we have 2 repeating decimals. So we're going to multiply both numbers by 100. In other words, we're going to move that decimal point 2 places instead of 1 place. So we're going to move it 1 place, 2 places. So that means we have 241, so 241. But remember, because it's repeating, there's another 41 after it. Okay, now we're going to take our first and put it under our second. So x equals, and we're going to line up our decimal, so 2.41. So the decimal part of it is lined up. So the 0.41, 0.41 are right on top of one another, and then we're going to subtract. This time we had 100x minus x. That leaves us 99x, not just 9x. And here, the decimal portion of it, right here, cancels out. So you're left with 241 minus 2, which gets us 239. And then we have to solve this simple equation. So right here it's multiplied. And I just want to remind you, because I haven't said it before, that if you don't see an operation in between the number and the variable, remember that means multiplied. So it's multiplied, so we have to divide. So now x equals 239 over 99. And you could go back to see if that could be reduced, or you could do the division to make sure that you are correct. But I'm going to, for the sake of time, leave it exactly like that. Alright, so for some of your assignment, you're going to be changing those repeating decimals to fractions, but some of your assignment is exactly what we were doing in our last lesson, deciding if a number is rational or irrational, and then justifying. So I want to remind you, for a number to be rational, so ratio null, rational, you must be able to put it into A over B form. So the first thing you should do, so in other words it looks like a fraction, the first thing you should do, remember, is decide if it is a rational or irrational by looking at what type of decimal it is. And then, this time though, we're going to justify by actually putting it in the A over B form. So here, we know that this is a terminating decimal. And yesterday, or in the last lesson, we learned that a terminating decimal can be put into A over B form, so it is rational. And so you're going to prove that. So it's terminating. My justification, I'm going to say what kind of decimal it is, terminating, and then can be put into A over B form, and I'm going to do that. 0.5 is the same thing as 1/2. So let's say you have a problem, just one more quick example like this. Square root of 2. The square root of 2, we learned yesterday that if the square root is not a perfect square, it is irrational. So I'd start my justification by saying it's irrational, not a perfect square, and then can't be A over B form. So you're really showing me that you understand why it's irrational. You know it's irrational because it's not a perfect square, so therefore it can't be put in A over B form. So you have those two different tasks today, practicing putting those repeating decimals into rational form, and then looking at some more numbers, like in the last lesson, decide if they're rational or irrational, and then justifying.